All right then, timer says it's time to start, so we're going to do that. So hello everybody, thank you for coming to this session. It's really nice, really good to see all these happy smiling faces. So my name's Steve and I work at Microsoft. I'm on the ASP.NET team. And I'm very, very excited to come and tell you about this thing, Blazor. But before we start, let's do a quick hands thing. How many of you have heard of this and feel like you've got some idea of what the idea of this thing is? Oh, that's good. That's like 2/3 of you. All right. Okay, cool. So just for those of you who are not sure about what this thing is, well, Blazor is a new single-page application framework that we on the ASP.NET team are creating. Now, at the moment, it's an experimental project and we don't know when it's going to ship, but it is our intention to ship this. We are making it available now as something that you can try out and give us feedback on as we build this up towards something that we can call a proper product. Okay, but with this talk, let's just set our expectations. So in this talk, my goal is not to give you a sort of step-by-step tutorial to like how to do lists and grids and things like that in Blazor, because honestly, you can just find that information on the web. That's boring. What I want to show you is a little bit more about why we're doing this stuff, like what is actually changing in the technology landscape that gives rise to this new thing. Why should there be a new thing? Why do you care? And how does it actually work on the inside? That's what this talk is really going to be like. So to get to that stage, we need to start by understanding a little bit about what the current status quo of web application development is. So this is probably quite familiar to most of you. I'm guessing most of you work on web applications of one kind or another. So your conventional situation is that you've got some code that runs on the server. Now it might be .NET, it might be Java, Node, Go, something else like that. It's going to run on some server somewhere. Maybe they're in a cloud, maybe they're just some dusty box under your desktop, but whatever. It's on a server. And then you want to make some UI appear in people's web browsers. And to do that, you're going to use one of these things, a single page application framework, something like Angular or React or Vue, something like that. Now, whichever one of these things you use, ultimately it's running on the JavaScript runtime. Okay, now maybe you write your code in TypeScript or something else, but it's going to compile to JavaScript. So basically, you're writing JavaScript code. And then you deal with making these two sides of the wire talk to each other. And that's okay, this is fine. But it's a little bit sad that over on the left there in server world, you've got a lot of flexibility and choices. You can use whatever language you want. You can use whatever technology stack you want. But when it comes to the browser side of the world, you're limited to things that basically look and feel like JavaScript. That's a bit sad. Wouldn't it be nicer if we could write code in any language and run it inside the browser? Well, that's why this new standard WebAssembly has emerged. It's not really that new anymore. It's about 2 years that it's been out and available now. It's supported in all current browsers, all desktop browsers, all mobile browsers. They're all supporting this. And in case you're not familiar with what it is, well, I'm going to show you in some detail later. But for now, let's just say it's a bytecode format. It's something that you can compile to, like Java bytecode or .NET bytecode. You can compile to this from any language that supports compiling to WebAssembly, and then you can run it inside your browser. And this allows us to bring other languages into the browser. Okay? So if we've got that, if we've got WebAssembly, then maybe that means we could run .NET on top of it. And if we had .NET running inside a browser, well, that leads us on to Blazor. Blazor is our UI platform running on .NET inside a browser on WebAssembly to allow you to build rich web UIs in a hopefully more productive and pleasant way than you've done before. So why would anyone care? Why would you want to write your web UI in .NET? Well, there's potentially quite a lot of benefits, and I'm going to go through some of them, but you don't really just want to hear me talk. You want me to actually show you some of these benefits in practice. So let's do some demos, okay? Let me create a bit of a Blazor application, and I'll talk you through some of these advantages that we can potentially get, starting with the use of the C# language. Okay, so I'm switching over into Visual Studio here, where I've created a project already, and I'll show you some of the code in it in a minute, but let's just start it running inside my browser here. And you can see that this is a pretty normal dashboard kind of application. It's got a few different pages in it. I can go backwards and forwards. That's client-side navigation. We're not making new HTTP request to the server when I do that. We've got some static content. We've got an example of this counter thing that just counts how many times you click on a button, which is, kind of dull, but, it shows you something. And then we've got this fetch data page, which is an example of making an HTTP request to the server to get some data and then rendering that as an HTML table. So, classic single-page application, the sort of thing that you would normally build with React or Vue or Angular, something like that, that would run on the JavaScript runtime. But in this application, there is no JavaScript at all. So to prove that, let's have a look at some of the code that's in there. And we will zoom in a little bit so we can see it. And you'll see what we've got in here is we've got some CSS, some HTML, we've got some CSHTML files, which are Razor files. You might or might not know that, depending on whether you've worked with ASP.NET before. I'll show you that in a sec. And at the bottom here, we've got these C# files. So this is a pure .NET application, which we're compiling and running on top of WebAssembly inside the browser. Okay, but what does this really look like? What are all these CSHTML files? Well, each one of these CSHTML files is a component. So Blazor follows on from a very similar architecture that you'll see in most modern SPA frameworks today, where the entire UI is constructed out of components. And a component is basically any piece of UI. It can be the entire application UI, it can be a layout, it can be an individual page, it could be just a small group of HTML elements, whatever you want. It's just components all the way down. You can nest these things and build a complex UI out of them. So, show you examples then. So let's start with the simplest one. Here we've got a bit of static content. So what does it take to have some static content? Well, it's completely trivial. So let's zoom in a bit. So as you can see, the simplest component is just some static HTML markup. We've also got this page directive at the top that says this is the component that we're going to use if the user is on our home page. Okay, so that's just static markup. We can also put some dynamic stuff in here, like this counter. And the code for that looks like this. Okay, what we've got is, again, we're using this page directive to respond to this particular URL. And then down here, we've got a functions block. And because this is a .NET application, we can put some arbitrary C# code into here. And so that's what we're doing. We've got this current count field, which starts at 0. And then in our markup, we're using Razor syntax, which is a way of using C# from inside HTML to display the value of current count right there. Then we've also got an HTML button, and we're saying when this button is clicked, we're going to call this C# method increment count. And the increment count method just does what you think it would do. It increases the value of current count, and the UI updates, and everyone is happy, and we get very rich. Okay, so that's a very simple component that displays some dynamic data. What about this one? This is a little bit more involved. It makes an HTTP request to the server. Let's have a look at the code in there. So again, we're using this page declaration at the top there. We're also using inject. And inject ties into ASP.NET's dependency injection system, and that gives us an instance of HTTP client, so we can make some requests. And if we look down here, right at the bottom, you'll see when this thing starts up, we're asynchronously going to do an HTTP GET request for some JSON data, and we're going to get that from this plain JSON file, just to show you that we can. And when that data comes back, we're going to deserialize it as an array of weather forecast objects. And we've defined the weather forecast type here as a nested class, and that defines the type of stuff on it. And then up here, we can use Razor syntax to say we'll iterate over each of these forecasts, and for each one, we'll display a little bit of HTML stuff. Okay? So I hope that seems reasonably straightforward so far. A component is a file that you can put some C# and some markup in, and then you can make it do whatever you want. You can do loads of stuff with components. You can nest them together, you can pass parameters into them, you can have events on them, you can do all kinds of cool stuff, and I'll show you a little bit of that as we go through. Okay, so we can use some C# to build our application. What else could we do that's useful? Well, we can take advantage of the full .NET ecosystem, and that gives us access to a very wide range of built, ready-made functionality. So an example of that, let's say you've just built this application and you show it to your manager or some business analyst in your company. What's the business analyst going to say? Well, the first thing is they'll say, oh, that's really cool, well done. Now I need to be able to export that data to Excel so I can do some business analytics on it. And you'll say, oh, okay, fine, right, I'll make you a CSV file. And they'll say, no, I don't want a CSV file. I want a proper spreadsheet. I don't want plain text. I want colors, I want formatting, I want graphs, I want formulas, I want all that stuff. And you think, oh, great, so, right, how am I going to make this Excel spreadsheet for you? And the answer to that is very easily, because it's the sort of problem that .NET developers solve every day, before the morning coffee, because it's very, very basic. What we're going to do is we're going to go and get a ready-made .NET package from the NuGet package manager that helps us to make Excel spreadsheets. So I'm going to go to Manage NuGet Packages, and I know the font's a bit small here, so I'll zoom in a bit. Now, I've already downloaded this one, just in case the network connection was a bit dodgy. This is EP+. It's like the number 7th most popular NuGet package of all time or something. It's millions of downloads because we all need to make spreadsheets, right? So I'm going to add this to my project here, and we'll get rid of all this stuff that it displays. And now I can start making a spreadsheet. So what am I going to do? First, I want to add a button that when you click it, it's going to trigger the download. So down here, inside my markup, I'm going to use an HTML button. Let's zoom out a bit. All right, we'll have an HTML button, and we'll say when you click it, we're going to call this method download file. And Visual Studio says, hang on, there is no download file method, and that is going to be a problem for me. So you think, all right, fine, I will create you a download file method. And the empty download file method is going to look a bit like this. Okay, so it doesn't do anything, just logs something to the console. All right, so now how do we actually create this spreadsheet? Well, we go and read the docs for EP+, and it tells us that in order to get started, you need to construct a new Excel package, and then we can add a forecasts worksheet to this spreadsheet. And then finally we'll say, okay, we want the browser to download this as a file, and the contents of it will be the bytes from our Excel spreadsheet. Okay, so let's compile that. And then I'll go back and I'll run that in my browser, and hopefully we'll actually download a spreadsheet when we click a button. So when that comes up, we've got our download button. I click on it, and what does it do? It says, aha, okay, we are trying to open forecasts.xlsx, and I click on that, and it's going to do the thing. It's going to open it in Excel, but it's going to be empty, right? Well, it's not quite empty. We've got this forecasts worksheet down here, you can just about see, but I didn't put any actual data in it, so let's put some in, shall we? So I'm just going to start dumping in some big blocks of pre-prepared code now. Firstly, I want to insert the actual data with the weather forecast. So I'm going to say, starting from this particular cell, I'm going to use a C# link expression to pick out what data I want. And I've got access to the full C# language, so I can use things like where clauses and things like that if I want to. But I don't. I just want to get all the forecasts data, and I want to put it all into my spreadsheet. Okay. Now, just to show that this is a real spreadsheet, let's do some fancy things. Let's do some conditional formatting. So we want the colors of the cells to vary between sky blue and red, depending on the temperature that we're displaying in that row. Okay, what else do we want to do? Well, I'm going to put in a formula. So I'm going to compute the temperature in Fahrenheit based on the temperature in Celsius using this Excel formula. Okay, and what else? Well, I'm going to dump in a big pile of markup, a big pile of text that you won't have time to read, and it's just going to say, let's set loads of things like horizontal alignment and background colors and bold fonts and other things like that, just to show that we can do all that sort of thing. So now when I reload and I come back and I download, this time, hopefully, when I open my spreadsheet, it won't be empty. It will actually contain the data that we've had in the UI just there. And that is a real spreadsheet. It's not just static. So if I change this 33 to let's say -5, then you'll see the cell becomes blue because of the conditional formatting and the temperature F updates and so on. So it's a real spreadsheet. Okay, very good. All right, so what was the point of showing that? It's just to show you that we can take whatever we want from the .NET ecosystem and we can bring it into the browser, run it as part of our Blazor application under WebAssembly. Now, finally, what's this about full stack development? Okay, well, the application that we've got here, the code in this application, this is a true client-side application. It does not depend on there being any .NET on the server at all. When we publish this, it's just static files as far as the web server is concerned. You can serve this from a Node app or PHP, or you can serve it from GitHub Pages or Azure Blob Storage or anything you want. It doesn't matter what's on your server. It's just static files, and I'll show you what those files actually are later. Okay, so standalone Blazor app does not depend on you having .NET on the server. But what if you do have .NET on the server? Are there potentially some benefits to having .NET on both sides of the wire? Well, yes, there are. Let me show you. So I'm going to create an entirely new Blazor project right now. So I'm going to create a new ASP.NET Core web application, and I'll give it the exciting name Web Application 181. There, you see I create quite a few of these things. And we can pick which of the many templates we want to use. We've got 3 built-in Blazor templates. We've got the standalone client-side one that I just used for the previous demo. We've got this next one which hosts it on a .NET web application backend, which I'm going to show you now. And then finally, we've got this mysterious server-side one we'll get to later on. Okay, so what does it mean to create a Blazor ASP.NET Core hosted application? Well, when you create a project with this template, you don't just get one project, you get 3. Okay, what are these 3? Let's have a look. We get a client, a server, and a shared project. The client is the same thing we just saw before. It's a set of Blazor components, and it runs under WebAssembly inside the browser. The server is a regular ASP.NET Core server, and we can put API endpoints on that, or whatever else we want to control what's actually going on the server. But the most interesting bit is the shared class library. And this is very simple. It's just a plain C# class library. But the cool thing about it is that it is consumed by both the server and client projects. So any code that you want to share between server and client, you can put there in the shared project. So let me just run this, and you will see that it does the same thing that we saw with the other application. Okay, so it looks the same, got the same functionality in it. But one thing that's a little different this time is this weather forecast data. It's not coming from a static file anymore. It's now coming from a real API endpoint on the server. And specifically, it's this one. It's this weather forecasts action, which is returning, random weather forecasts. But the important thing is we're returning an enumerable of weather forecast objects from the server here. And then on the client, you'll see down at the bottom, we're fetching the weather forecasts objects. So the server sends a weather forecast, the client receives a weather forecast. We don't have to define the weather forecast type inside our client project because that is coming from the shared project. So server and client are trivially sharing code, not just necessarily for fixed fields like this. We can put actual logic in here or validation rules. Anything we want to share between server and client can go there. So that potentially gives us a very productive way of building a full stack web application. Now there's other benefits of running on .NET Core as well. .NET Core is incredibly fast by modern standards. The tooling that we have for .NET Core in Visual Studio and VS Code is absolutely industry leading. Everybody is well aware that the IntelliSense is really good, and it's very nice to work with as a developer. And also, it's a stable ecosystem. .NET is expected to be used for projects that live on the order of 5 or 10 years or 15 years. We don't completely change stuff like every 3 months. So, you've got some decent guarantees that you're going to be able to build your project over the long term here. Okay, so that's some of the benefits of doing this, but I now want to switch gears a bit and think about how does this stuff actually work? What is going on behind the scenes here? Well, the way this works is a combination of 3 technologies working together. So I'm going to show you each of them in turn to build up this sort of layer cake here of technologies. And the bottom of the stack here, the place where it starts, is with WebAssembly. And I just told you a minute ago that WebAssembly is a form of bytecode that you can run in your browser. But have you actually seen WebAssembly bytecode? Do you know what it looks like? Do you know how to create the bytecode yourself? Let me show you. I'll give you a little demo. So let's see. Can I just change this font size a bit? Let's have... No, I can't. Never mind. All right, so I've got some files here. I've got this file Fibonacci.c, and that is a very simple implementation of building the Fibonacci series in C. Now, the Fibonacci series is just a series of numbers that's defined mathematically. It goes 1, 1, 2, 3, 5, 8, something like that. I don't know. And there's a simple rule that defines each term in the series, and I've written that in C. Okay, so if I show you the source code for Fibonacci.c, hopefully it'll not be too scary, even if you've not seen C before. It's got a main function. It's saying we want to call print Fibonacci to get the first 10 terms from the series, and print Fibonacci takes that number of terms, and then it loops until we've printed all the terms we want. We print the current one, we compute the next, we print the next, we compute the next, and so on. So that's written in C, and I could compile that to make a native application if I wanted. But I don't want. What I want is to compile to make a WebAssembly application. So I'm going to do so using the Emscripten C compiler, which is the compiler that everyone uses to create WebAssembly bytecode. And I want it to compile Fibonacci.c to produce a version of Fibonacci that can run under JavaScript. Okay, so when that has done its job, if I view that, you'll see we've just created these two new files. Fibonacci.wasm here on the right, that's the actual bytecode for this application. Well, for this, trivial few lines of code. And I'll show you what's in there in a minute. Also, Fibonacci.js is something that you can load into your browser in a normal way to execute it. So it's a wrapper around the WebAssembly file. So if I want to actually run this, I need to load it in a web page. So I've got this index.html. Let me just show you what's in there. Not very much. Probably not even technically valid, but it's good enough. All it is just a script tag that loads Fibonacci.js. Okay, so let's start running that in a browser. Okay, let's go to localhost port 8080, and we'll open the console, and you'll see that we do indeed run the thing, and it generates the first 10 terms of the Fibonacci series. Okay, but what is this code that's actually running? What does it look like? I'll switch over to the debugger tab, and let's have a look and see what we've got. Well, if only I had a big enough screen to do that. All right, there we go. All right, then, so what we've got here. Oh, actually, I want to compile this again with debugging enabled. I want source maps here, so I'm passing this extra parameter. Okay, so now I've done that, I'm going to be able to show you this in a more useful way. Because we've got source maps, you can see we now see the actual C source code here in the browser's debug tools, and I can even set a breakpoint on it. So how cool is this? We've just compiled some C code to something that can run in a browser. We can see the C code, and we can step through it in a debugger in the browser. Okay, so that's pretty awesome, but we're not really running C here. What we're really running is WebAssembly bytecode. What even is that? What does it look like? Let's have a look at the actual underlying bytecode that's being shown in the form of C. So if I switch over here, this is WebAssembly bytecode. Okay, so normally on disk it's in a binary format that you can't possibly read, but Firefox shows it to us in a human readable. Well, I don't know if. It depends. If you're the right kind of human, then maybe you can read this sort of thing, but it's difficult to make sense of, I appreciate. But we can understand some of it. I hope so anyway. If I scroll down a bit, you might see some bits that make sense. Okay, we've got a function called print Fibonacci. All right, and what does that do? Well, it does things like it declares a couple of consts, 0 and 1, and that happens to correspond to these two constants here in our C source code. And then what does it do? Well, it does a loop, just like the loop in our C code, and it does lots of numerical additions and things, and then eventually it calls printf, and that's going to actually print stuff out. So if we wanted to, we can set our breakpoint here inside WebAssembly and start stepping through it like that. So this is what WebAssembly bytecode looks like. It's a stack-based virtual machine that operates on a bunch of different numeric types, and it's very, very fast. Code compiled to WebAssembly typically will run within a factor of 2 of the equivalent native code. So if I just compiled this to native x64 machine code and ran it, it would only be about twice as fast as running it under WebAssembly in Firefox at least. Other browsers vary slightly. Okay, so that is the bottom of our cake there, WebAssembly. And once we've got that, we can build on top of it something like .NET. So how could we run .NET on top of WebAssembly? Well, one way that's quite obvious is we could somehow translate the .NET code into WebAssembly code. And if we could do that, it would run. So that's the first way we could do it. The other way we could do it, the way that we actually have done it, is we could compile the .NET runtime itself to WebAssembly, and then we could just run normal .NET assemblies on top of that. So that's what we've done. We've taken the Mono runtime and compiled it to WebAssembly so it can run inside a browser. Now, why did we do Mono? Well, Mono is one of the 3 .NET runtimes that Microsoft makes. And why are there 3 different ones? Well, historical reasons. But the point is, as a developer, you don't really need to care about the differences. They all can run .NET code. You just use whichever one is available on your platform. And Mono is the one that we can compile to WebAssembly because it's the most portable of them all. So how does Mono run on top of WebAssembly? Let me show you. So here's our application from before, remember. Now let's think about what we're actually sending to the web browser here. This is the initial HTML that's going to the browser. You can see it doesn't have a lot in it. The only interesting thing it's got in it is this script tag, which is going to load blazor.webassembly.js. And that is a standard JavaScript file that ships inside Blazor, and that is what knows how to load up the Mono runtime under WebAssembly and load your .NET application into it. Okay, let's actually see that happening then. Let's see what we're sending over the wire. If I go over onto the Network tab here and I hit Reload, then we'll see what we're actually transferring to the browser is the following. Firstly, we're sending that HTML file, which I just showed you, and that tells the browser to load this CSS and this JavaScript file and other things. And after it's done that, the blazor.webassembly.js file is going to load mono.js and mono.wasm. And that is what we get when we compile Mono to WebAssembly, the WebAssembly bytecode and a JavaScript wrapper around it. And so that can then start running inside the browser. And when we've got that, we can load some .NET assemblies into it. So that's what we're doing here. We're loading the excitingly named Web Application 181 Client DLL, and that has got all these other dependencies, system.core, system.dll, blah, 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 blah. We load all these into the browser, and they can just run. These are normal .NET assemblies, nothing special WebAssembly about them. It's just regular assemblies that we can load and run under Mono. So you might be thinking, okay, but you're loading an entire .NET runtime into a web page. This is going to be like 100 megabytes or something. This is insane. So how big is this web page anyway? Well, it is this big. It's 1.95 megabytes, which is pretty small for an entire .NET runtime and the libraries we need to run our application. On the other hand, it's kind of big for a web page, right? 2 megabytes. So yeah, we're aware of that. And our goal is to make this as small as we can, obviously. We think we can make it quite a lot smaller than that, but this is as far as we've got with the optimization so far. In a lot of cases, it's not going to make any difference to you for something like an intranet application, but obviously for a public-facing internet application, it's something you want to bear in mind. Okay, so that's Mono. Finally, the top and most delicious layer of our cake is Blazor itself, and that is the UI stack that's designed to run on WebAssembly. Okay, and I've already shown you a bit of Blazor code. For example, I showed you this counter here. But again, how does it actually execute? We can get the idea that this is .NET code, so it can run under Mono under WebAssembly, but what is all this stuff? Like, how does this execute? This is text. You can't execute text, can you? So what are we doing here? Well, the answer to that is that the Blazor compiler converts this stuff into a .NET class that can execute. And if you want to see the class itself, I can show you. It goes into this hidden top secret location that no one knows about, and this is what actually gets generated. It's a class, which in this case is called counter, because that's what our file is called. And if we scroll down a bit, you'll recognize some parts of it. So that's the code that we just wrote, and that just gets dumped straight into the middle of your class. And then as for this markup up here, what we do is we translate that into a bunch of rendering instructions. So it's not just a big old string here, it's a set of instructions to do things like open an element, add some content into it, open an element called button, put an attribute on it, and so on. So what's happening at runtime here is every time we want to render your component, we render it to an in-memory data structure that represents the UI tree. We call it a render tree. This is a similar technique that many other SPA frameworks use. Instead of operating on the DOM directly, they operate on a data structure in memory. And then every time your component renders, we can diff the data structure against the previous version for that one. And we can figure out exactly what's changed in the UI, and we can apply the minimal updates to the diff, to the DOM. So if I go over here and when I click this button, the only part of the UI that's getting updated when I click this is that text node there with the 3 on it. So it's very, very efficient in terms of how we actually update the UI. Okay. So that is our completed wonderful technology cake there, going all the way from WebAssembly up to Blazor running on top of that. But I've only shown you one side of the story so far. There's actually more to Blazor that you can do than just build applications like that. So let me tell you about other ways that you can run this. So what I've shown you so far is how we can have a browser and we can have Blazor running inside of it on top of Mono, on top of WebAssembly, and then we can do all the UI executions, we can build the diffs, and we can apply the DOM all entirely inside the browser. And that's a true client-side application. But this architecture is very flexible. Because we've got this separation between how the UI updates are computed and how they actually get applied, we can restructure the application in some interesting ways. For example, what if we were to take Blazor out of the browser and run it on your server in the cloud instead? And then when it comes to actually displaying the UI in the browser, we could compute those diffs on the server and send them to the browser over, say, a WebSocket connection. It could apply the UI there, and when there are events, it can send them back up into the server, and this cycle continues. So this is a method that we've called server-side Blazor, or to give it its new name, Razor Components. So this approach turns out to be extremely compelling in a lot of situations. I'll talk about some of the pros and cons in a minute. But a lot of people are very, very into this approach. And do you remember before I said that the client-side version of Blazor is it's experimental? We don't know exactly when it's going to ship, even though we do plan to ship it. Well, the server-side version of Blazor, that's not experimental. We know exactly when that's going to ship. That is committed to be part of ASP.NET Core 3.0. So that's something that you are definitely going to be able to use in production pretty soon. Okay, so I'll talk about the pros and cons of this in a minute, but let me just show you it actually working to illustrate what I've just said. So I'm going to switch over yet again to another project, and this has been built with the Blazor server-side template. So when I run this now, you'll see that once again it looks more or less the same and behaves the same. I've got this extra page at the bottom, which we'll get to in a minute, which I've added for this demo. But you know, it does the same things. But actually, I want to show you this in Chrome because it's got a better debug tools for WebSockets. So first thing to notice is look how quick this loads. When I click reload, it's just boom, it's just there. And in terms of what we're sending over the wire, it's far, far more minimal. When I reload with hard reload, so it's not using the cache, you'll see that it's not 2 megabytes anymore, it's 100 kilobytes. So it's far, far more lightweight. In fact, we could make this much smaller. We could probably get this down to about 30 kilobytes, particularly if we took all the bootstrap and stuff out of it. So it's very lightweight. And we're not fetching the .NET runtime into the browser anymore. What we're doing instead is we're opening a WebSocket connection back to the server. And that's what this _Blazor request is here. That's for a WebSocket URL. That's the WS there in the URL. And if I click on that, we can see what's going over the wire, or we can a little bit. You'll note that whenever I click this button, you'll see a little bit of traffic goes across the wire. So we're sending a message to the server to say, hey, there was this event. That's a 371 byte message. And the server says, OK, here's the updates to the UI in response. And that's 61 bytes coming back. And then we've got some bits of housekeeping that come with it as well. But the point here is it's extremely lightweight. The total amount of traffic in response to an event like this is measured in the tens or hundreds of bytes. It's incredibly minimal in terms of wire traffic. Okay, so that is showing you it working, but let's talk about the pros and cons of this compared with client-side Blazor for a minute. So on the pros side, the most obvious one is that it takes all the load away from the client. The client becomes an extremely thin client. All it has to do is apply these UI diffs that the server gives it. So you're sending it very, very little code. You're just giving it the actual UI. It's incredibly fast. It works with the most ancient browsers. It's very, very compatible with whatever kind of client you want. Because we're running the code on the server now, we're running it on the full .NET Core runtime, which means that there's absolutely no scenarios where you're limited in terms of what code you can write. You've got access to your full server runtime, all the resources available on your server, and everything is going to be stupendously fast. And then finally, in terms of simpler architecture, well, I'll explain that in a minute, but let's just talk about the cons as well, because there are some. Because we're depending on the server now for every single UI update, this application cannot work offline. The client-side one can work offline. It can be a PWA or something else like that. But the server one cannot. It's using the server for every UI update. The other main drawback is latency. Now, this is the sad thing about physics. The physicists have not yet figured out any way to make light any faster, and light is disappointingly very, very slow. So if your server is 200 milliseconds away in terms of speed of light, well, it's going to take 200 milliseconds for every UI update. That's just like basic physics. We can't do anything about that, unfortunately. So for an intranet application or a geographically distributed application, it's not an issue. But if you are for a public application, if your server's in Australia and you're here, going to be a bit of latency. So you have to bear that in mind. And finally, you're using your server resources for every single UI update. So you're paying the cost of that CPU time, which is different from on the client, where the client brings their own CPU time and you don't have to pay for it. Okay, so what do I mean by simpler architecture? What I mean by that is you potentially can remove one of the layers from your architecture diagram. Normally, when you've got some code running on the client, if it wants to run some code on the server, you have to go through some HTTP endpoint. So you want to do a database request, you're going to make an HTTP call, and then it does the database request. But with server-side Blazor, your code is already on the server, so you don't have to go through an extra hop to get to the server. So to give you an example of the benefit of that, let's consider some kind of funky machine learning scenario. Okay, so I've got this reviews page over here where I want people to write some reviews of, I don't know, stuff in general, okay? And our business analysts tell us that it's good for business when people write happy reviews and it's bad if people write sad reviews. So we need to know if someone seems too sad, and if they are, we're going to block them from submitting the review, okay? That seems reasonable. So to do that, we're going to want to do some fancy machine learning thing to figure out whether the user is happy or sad. But we want to run that on the server because our machine learning model is very computationally expensive, and even if it wasn't, it's highly proprietary, and we don't want to disclose how it works to the client. So here's how the code for this is going to work. We've got this reviews component here, which says, tell us what you think. It's got a button, which, to be honest, doesn't do anything. And then we've got a text area below that, and we've got an onInput event. So every time there's a keystroke, we're going to call this update score method, and it's going to figure out what text the user has just entered, and then it's going to call our machine learning model. This is a real ML.NET model. I'm not going to go through the code, but it's kind of simple. So it takes some text input, it produces a probability of happiness where 0 is like desperately sad and 1 is the highest level of ecstasy that a human being can possibly experience. Okay, then we're multiplying that by 100 to get a probability, and this is what we're doing. So I'm loading a pre-prepared machine learning model called sentiment.zip, and I can predict someone's happiness based on that. So I am then predicting their happiness, and then I'm passing that updated happiness to the happiness scale. The point of me showing you this is just that I don't have to go through an HTTP request to do that. If I want to call some server-side code, I just call it because my code is already on the server. So if I'm over here and I write, this is terrible, it sucks, I never want to see this again, you can see that the user is extremely unhappy. But if we change it to, this is great, it is nice, I want to see this again, then we know that our user is much happier and we can accept their review. All right, so that's server-side Blazor, okay? Finally, the third way that we can run a Blazor application. What if we want to build a native desktop app? We didn't think about that. So what if we want to build a Windows application or a Mac or a Linux desktop application? Could we use Blazor for that? Yes, we could. So we could take the same Blazor components that work client-side on WebAssembly and that also work server-side, and we could run them on type of .NET Core, which is cross-platform, okay? If you didn't get the message yet, it's been cross-platform for several years now. So we can run Blazor on .NET cross-platform and use that to update the UI inside an Electron application. Let me give you a very quick example of that. So we did an experiment to see if we could port the Azure Storage Explorer desktop application to Blazor. And so that's what this is. So it looks like a regular .NET application. It is a .NET application. It's all nice and fast. It's very scalable. You know, we've got this grid with 100,000 items in it. We can do all the things like fetching some stuff from a network. So let's see what we've got inside the ASP.NET Core test account. We've got some screenshots that someone's added of something. I can download that. I can launch that in the operating system image viewer. So here, I've got a screenshot of something from Windows. Great. And this is a set of Blazor components. Everything you see here is a big nested hierarchy of Blazor components, which is running under Electron to produce a very responsive cross-platform desktop application. So that's yet another way that you can use your Blazor components. So there we go. That is hopefully pretty much the whole story of what we can do with Blazor at the moment. It's an actual single-page application framework that's built with .NET. It's got all the kind of features that you would need to build a realistic, large application there. We can run it on the client. We can run it on the server. We can run it under Electron. And you should try it out. So to try it out, go to blazor.net, download it, follow the tutorials, and become a more happy and fulfilled person. So I hope that's fun for you. Enjoy the rest of your conference, and remember to press the buttons on your way out. Thank you.